The LMS Railway has for long regarded scientific attack on the many problems of transport as being of great importance. Improvements and economies in methods and materials can be made with the help of trained minds. The Research Department is the willing helper of all LMS departments, ready to cooperate with them and to bring its special technique to bear on their problems. It is not intended to be a usurper of the proper functions of the departments. The Advisory Committee, which controls the work done by the Research Department, consists of distinguished scientists and the technical officers of the company. The chairman is the Vice President and Director of Scientific Research. Lord Stamp takes a personal interest in its work and is here seen discussing a problem with the committee. In 1935, the company constructed at Derby a research laboratory where scientific work in engineering, metallurgy, paint and textiles is carried out. The research department tests materials purchased by the company to ensure that they conform to required standards. Much of the work of the textile section is of this type. Materials used for covering carriage seats, for instance, are subjected to very hard usage. This machine reproduces the wearing conditions, and seat material can be compared in this way with standard samples for wearing qualities. Strong sunlight, which may fade material, can be artificially reproduced for testing purposes in this fugitometer. Samples are exposed for 100 hours to the glare of the arc lamp, equivalent to many months of strong sunlight. Cloth purchased for uniforms must conform to a specification which, amongst other things, calls for a minimum number of threads to the square inch. In the controlled temperature and humidity room, fabrics are tested for breaking strength. This machine registers the load necessary to break a canvas sample. Paper, which is used by the company in large quantities, is tested for bursting strength. In almost all goods yards, wagons are moved about by ropes and capstans. It is of importance to the company that the rope used should be of great strength and suitable in every way for the heavy work it has to perform. The research department keeps a constant watch on the rope bought by the company and tests samples of every lot in such a machine as this. The machine tests the rope sample to destruction and registers its breaking strength. All over the railway, paint is wanted. It is important that the paint used should be the best for the job for which it is required. Here again, the research department renders valuable assistance to the using departments. The paint laboratory possesses a complete miniature paint mill in which new types of finish can be developed. Samples of paint from manufacturers are subjected to a variety of tests. Sample panels are made for testing by applying paint by means of spray or brush. Tests for covering power are carried out, and the sample panels are tested in the weatherometer, which subjects them to alternate arc light and water spray. 6 weeks in this apparatus is equivalent to a year of ordinary weathering. Other paint samples undergo a long period of exposure to normal weather conditions. By regular observation, much valuable data is obtained on the wearing qualities of paint. The paint section was responsible for the introduction of a system of coach panel preparation before assembly, which ensures that the panels are in fit condition to take the coats of paint and will not rust. Another function of the department is the analysis and exact measurement of performance. This work is of great value since it gives accurate knowledge about the materials on which efficient working depends. The investigators responsible for this work are highly trained in devising tests which will reproduce actual working conditions. This machine is testing the strength of a riveted boiler joint to which a weld has been added to render it steam tight. The test continues night and day for many days. This machine is testing small samples of the steel used for rails. The samples rub round against one another for long periods, and the amount of wear is determined by weighing. This is an ingenious model of a wheel tire running on a rail. Sideways motion is imparted to the tire, and by weighing and measurement, an accurate estimate of wear, and hence of the suitability of various types of steel, can be arrived at. The research department was recently responsible for a prolonged investigation into the causes and cure of tire failures, with very satisfactory results. For several years, every tire failure on the railway was minutely analyzed by the department. The procedure was somewhat as follows. As soon as an examiner finds a flaw in a tire, he reports it to the research department, who send a man to examine it. This representative asks for the flawed section to be cut out. When the first cut is made, the tire, which of course is shrunk onto the wheel center, springs open, and the investigator measures the opening of the cut. The wheel center is removed and its circularity tested. All this data will be recorded and may prove to have an important bearing on the cause of tire failures. The flawed section of tire is dispatched to the laboratory, where it is given a preliminary examination and marked for breaking and cutting. The section is then broken open under a steam hammer at the flaw. It is then returned to the laboratory, where the flaw itself, in this case a minute fracture, is carefully examined. The section is then sent to the engineering workshop, which is part of the laboratory, where it is cut into specimens for laboratory testing. These specimens are made with great accuracy and finished to exact sizes by skilled craftsmen. One specimen is placed in the Avery machine, which consists in essential of a pendulum hammer. The blow breaks the steel sample, and the kinetic energy absorbed in the breaking is registered on the scale. This gives a measure of the steel's resistance to shock. Another specimen is tested for resistance to fatigue. In this machine, it is flexed at the rate of 2,400 reversals per minute. Another sample of the tire is tested for hardness. A hard steel ball applied at a known pressure for a known time makes an indentation in the surface of the steel, which is measured under a microscope. In the Buckton machine, the breaking strength of the tire steel is tested. The sample is subjected to a vertical load, which is measured by the beam balance. From the results of a continuous and thorough examination on these lines of all tire failures, the research department was able to make recommendations about the finish of tire surfaces, which, there is every reason to suppose, will greatly reduce the number of tire failures in service. The new finish for the inside of tires is produced by a tool of exceedingly hard material, and it is considerably smoother than either of the older finishes. Another function of the research department is the investigation of practical problems which confront railway operating and technical departments. An interesting beginning on a piece of new research of this character is an investigation into the causes of train tail lamps going out. Tests in a wind tunnel suggested that tail lamps are not readily blown out, and that they are more likely extinguished by vibration. This apparatus was made in the laboratory to test the merits of various types of bracket for reducing vibration. Recently, the research department investigated the causes of hot axle boxes. The white metal and the lubricating oil were found to be satisfactory. Another possible cause of the trouble was the axle box pad. It was discovered that the pad gave off a fluff, which formed a ridge on the bearing surface and prevented proper lubrication. Numerous experiments were performed with the object of finding a suitable yarn for axle box pads which would not give off this harmful fluff. Eventually, a yarn made of a mixture of cotton and wool was found to be suitable in every way, and the new standard axle box pads were introduced. These pads give off no fluff, and a perfect bearing surface is preserved by their use. The direct result of these experiments has been a large decrease in the number of coach casualties due to hot boxes. An investigation was recently made on the subject of sheets for sleeping cars. A number of sheets were examined and the various causes of wear considered. Amongst these, the effect of laundering is important, and samples of different materials for sheets were washed in a laboratory washing machine 120 times each. Recommendations were made as to the most suitable and economical material for new sheets for our sleepers. Another interesting investigation is that which is being carried out at present at Medbourne on the welding of long sections of track. 2,200 feet of track over which no traffic passes was welded into one solid length. A control length of free track is established nearby to provide a comparison. The experiments are directed towards determining the expansion and contraction and the buckling of the track caused by temperature variations. Careful measurements of all track movement and stresses are taken throughout the welded length each time a party of research workers visits the site. Measurements are taken during hot and cold weather. The experiments will probably be of long duration because they depend on the uncertain English climate. One of the best known and most spectacular pieces of apparatus in the research department is the wind tunnel. This consists of a tunnel some 4 feet square and 30 feet long, having at one end a fan which sucks air through the tunnel. Experiments of great value have been carried out here on the design and streamlining of engines and coaches. The streamlining of the Princess Coronation class engines was developed here, the investigators starting their experiments with a model of an engine of the Princess Royal type, and working with models of various shapes till a design which combined beauty with efficiency was developed. The models of the engines were made with detachable fronts so that different shapes could be tried one after the other. Experiments on smoke deflection were also carried out here before the Princess Coronation class design was finally decided. Today, the Princess Coronation class locomotives are among the finest examples of streamlining on any railway in the world. In the wind tunnel too, the designs for the 3-car diesel train were tested in miniature. It is a delicate and highly skilled job to measure the forces induced by an airstream on a tiny scale model, and the results are now being checked in actual practice. Throughout the research department, it is evident that theory and practice go hand in hand, and there is no doubt that the department is and will continue to be a great power for improvement in this wonderful transport organization.